Hello and welcome to a new episode of Today You Learned. So today, not really a presentation, just want to quickly dive into the demonstration that I have. It's a combination of exploitation, so in this case it will be still a bit phishing, but the human component will be very minimal. We will actually abuse a vulnerability in a browser, and then we will continue to steal cookies, thus bypassing all MFA and other mitigations, and still get access to all the browser sessions. Okay, so let's dive right into it. So we go into the demo, and as you can see on the right side, we have our victim that is just using several browsers, and at the left side we have our hacker. So the first thing I want to do is I actually want to have a shell open on my victim. So for that I first have to set up a listener. Or at least set up a C2 component, command and control. So let's dive right in. I have a connection that I can set up to a server on the internet. So this is a server on the internet that just has a public IP address, and then we can actually continue a screen that we have right here. So this is the software that we will be using. It's called Octopus. It's an open source software you can find on the internet, and this actually has several options to configure and to create listeners, right? So it has HTTP and HTTPS listeners, set up sessions, and then even create the payloads that you want to be executed on your victims in PowerShell, on HD8, and executable even on DigiSpark, which would be like a rubber ducky type of payload. Okay, so let's start with picking our URL. So this is the URL that will have the listener, the insecurity.be one for our C2 demo, and then the listener will have the name listener1. Okay. It will also, I already prepared some keys, which you can do for free, of course, some SSH or HTTPS keys that we are using so that it is a proper valid listener, right? So now we created the listener itself, and then we need to configure the listener like this, generate HTA. This means that we actually will be actively listening for any payloads that are coming in of the type of HTA. So what do we really want here? We can just copy paste this to our victim, and then we will have a shell, right? It should connect back, so our victim should connect back to our public listener. However, I'm going to do it a little bit differently. I actually have a vulnerable version of Chrome right here. It doesn't really show it, but this is a vulnerable version, not the most recent one, of Chrome, and the only thing I have to do in Chrome is visit a website. For example, someone has sent me a phishing link, an advanced phishing link, saying click here if you want to get a free iPad Pro. That's the URL. I would suggest not to visit that website for real, but if you do and you have a vulnerable version of Chrome, then you will actually have a connection being set up to my listener, which is not that good, of course. So now we have a connection connecting back to this system right here. As you can see, it has worked. The HTTPS should not be able to show that, well, the HTTPS should be configured so that we not see the yes, no. So that's something that is still a small bug in the exploit code, not important. But as you can see, and there's a very small artifact because we use HTA now, that is that little window that we see here, very minimalized. With the other options, for example PowerShell or an executable or a spoofed executable, we would not have that artifact. Okay, but we have our connection right here, so we should have now a shell. If we list all the shells that are connected from the C2 environment just running in the cloud to our by the way, newest Windows environment, so this is the most recent Windows 11 to date. Fully patched, except Chrome, of course. So here, and as we can see, we are running in the process ID of a PowerShell executable. The username is Philip. It's not connected to any domain, and we are in. So what can we do now? Any comment that we can type here will actually be sent. No, first I have to open the session, interact with session number 1. So now we are connected to the session. So now if I type a comment that is not any of the options, it will actually send that comment to the victim, and the victim can actually just close the browser, do whatever he wants to do. We can still connect to it via this way. So, for example, what some of the things that we can do, this system, if it boots up, it actually automatically logs in. So that's one of the things that the hackers can try to accomplish or get. For example, we perform a query of the registry, which we can do as a normal user. We are not administrator currently. So this win logon default username value, if it is empty, then it means automatic logon is not enabled. If it has a value, in this case the value Philip, it means that default logon is enabled. And if we then change the query from default password to default username to default passwords, then we will actually see the clear text password, because usually, a lot of times, that password is clear text in the registry, as you can see right here. So that's the username and password of the local user on that system. So that's already part one of the phishing. Of course, a real hacker will not stop here. He will actually try to become administrator on the Windows system. First, let's verify if we are already administrator. If UAC is, for example, disabled here, then we would actually already be administrator. That's not the case here. It's a pretty default setup. So we have no results, meaning that open files has failed, meaning we probably have no permissions for that. So we want to become an administrator. One way to do that is by just relaunching, so running this command will actually start this process once again, so the one connecting back to the listener, but in this case, we will try to run it as an administrator. So this is something that we sent to the victim. This is more like a social engineering attack. So if we do that, we actually get a pop-up right here saying that some HTML application host wants to become administrator. Okay, so if you don't trust it, very important, click no. Nothing will happen. We have an error right here, but of course nothing stops the hacker for just running it again, and we can run it again until the user clicks yes, because he's tired of it, right? This is also called a fatigue attack. So we just run it again until the user says yes, because he wants to get rid of it. So if he clicks yes, we actually get a new connection, a new session. We even see two different connections right here. So if I go back and list the sessions, we can see that we now have two of them, and the second one has an asterisk next to the name, meaning this is an administrator session. So if I interact with two and now I type open files, we should actually see some output. The output could be that there are no files open, no problem, but this is a comment that just tells you if you're an administrator or not. Just one of the several comments, of course. So great, this means that now the hacker is becoming, or has been, administrator on the server. That's one way. So for example, what can we do now? Because the target, the destination, is to get passwords from the browser, cookies, and so on. So let's do that by first going to the desktop. So now we have changed our current working directory to the desktop of the user. Let's download something. So let me first download it. So this is just a command, IWR, invoke web request, to download a file from a server and then write it to getfiles.bat. But let me show you what the file actually does. So this is the file itself. So it actually just is a combination of the several copy commands, right? So we have like this, maybe a little bit bigger. So it just creates a folder called DPAPA loot. It's part of a data protection API investigation that I did. It also makes some registry saves, but it mostly just makes a folder and subfolders and then copies, xcopy. We can see several xcopies right here and here and here. So it just copies files. So this means that this script actually also has some significance when run not as administrator. It's of course better to run as administrator, but doesn't really have to, because most of these things can actually just be copied out as a normal user. So that's all this script does. It just copies files into a certain destination directory, that would be this directory, and then it compresses that archive into DPAPA loot.zip and puts it in the C drive, and that's it, and then it cleans up after itself. And that's what we can do now. We can see that the download has worked. Now we have to launch the script, of course. So that's what happens here. So now the file is being launched. It's in the background. You won't see much. You might just see the creation of that folder where temporarily all the files are being copied to. Once that has been done, the zip file is being created. The zip file is here on the desktop, but the zip file should also be on the C drive. That's just for easier copy. If not, I will just put it there because it's easier to copy it out, not important. So that's the file right here. So here we are back into our connections. Let me go back to the, we can just see here that the file should actually be created. Let's go to the root directory. It's just for easier downloading of the file because we of course need our file. So downloading the file is fairly easy. Just download. And now it is being downloaded from the victim over to the hacker environment. Of course, I made it on the desktop. I created it on the desktop. Real hackers will not be so plain about it. I will just do it on the C drive or in a temp drive or somewhere else. It doesn't really matter. So now it should be downloaded on my system right here, on my cloud system. So let's go into a new directory in the same system. So we're still online on the C2 demo system. We have our downloads folder under Octopus. If we look what is happening there, then we see our zip file being downloaded. It has a little bit of a strange name, but it seems to be the full file, 20 megabytes. Let's maybe put it somewhere else so we can download it to our Kali environment. So this is a clean Kali environment. So I just put it in the TMP folder. So now I create a new window, but on my local Kali environment. Let's maybe first become root. So now I can actually just run this command. Let me just start it first, and then this should work. Okay, so what I do now is I copy the file over SSH from my source, from the remote host, from the TMP folder to my local system where it should be downloaded right here. Okay, so now we have the files, the sources, the copies of the files of browsers and the user settings and registry and things like that from the victim running on the Kali system. So let's unzip it. Let's have a look what is all in there. So we can go there like this, maybe make it a little bit bigger. And as you can see, it's actually a little simulation of the C drive of the destination of the hacker, the victim, sorry. So we have our victim folder bit based. So if we go into user, for example, we have a user Philip, which has app data, into user.dat, which is of course the registry. We have a Windows folder with registries. We have other things like program data. Now to parse this and to convert this into something that we can use as a hacker, for example, we can use a toolkit called Diana. It's also something that I created. So Diana, it is fairly simple to install. I even created a one-liner for running on Linux. So I actually have to do this as a normal user, preferably. Cloning, there we are. Okay, so it's being installed right now. It's just a couple of Python scripts that depend on a library. And with this, the Python script is installed. So let's go back into our roots. In our root folder, maybe a little bit bigger. So what it does is actually a combination of different scripts, all created to be used offline without a Windows system. Can work on Windows, of course, too, but without a Windows system, to decrypt secrets that are installed into a Windows environment. All kinds of different secrets. Most of them are actually data protection API based, which is an API by Microsoft to store secrets, credentials, and other things. Some of them are even DP API next gen, so the new version of DP API, but some others don't really use DP API, data protection API. So for example, one of the scripts that is pretty useful to run the first time is actually the registry decryption or parsing more. So this actually by default reads out the 4 main system hives. If you just run it without options, and it assumes that, then it will assume that it's being run from the C folder. So now it will just parse these 4 SAM software system security folders. So this is what it's being using or has been using for this output, and it just reads out the different things that are in there. So we have our local users. If there are secret questions, it will find them too. If there are local hashes, it will have them too. So we have our local hash for user Philip right here, for example. The other ones are empty, so administrator has no password. If there are domain cached caches and so on, and even if there are default Windows logins, which we already know there are because we did it manually. And as we know from manual recovery, it's in the registry. So this reads out the registry, just prints it out as well. Same for other service credentials as well. If they are clear text, they will be shown. Okay, so that's the registry. More on Diana later maybe. Another cool one is, let me show you. This victim actually has another secret. If I lock it, one of the options to log in is actually using a PIN code. So this user does not want to type in his full password every time, and he decides to use a PIN code. So PIN codes are actually stored using DP API next generation, so NG. So with this command, the ngc parse, and then we give it the folder of where the ngcs are stored, which is the default folder. There's no really possibility to change that. It will try to parse that, and in this case, it has found some GUID that is probably a PIN GUID, which it seems to be. It is also stored as a software provider, meaning that this virtual machine is not using TPM, which it actually should. If it's Windows 11, it should have a TPM, preferably version 2 and so on. But in this case, that's not the case. So this is the identification that he has found for that. So maybe we can try to brute force the Windows hello PIN. It's 4 or maybe 6 characters. Should be easily brute forceable, right? So for that, I also created a script as part of Diana. It's the pin pass decryption, and I ask it, I can provide the pin if I know the pin. Maybe I have seen it or I know it. If not, he will just walk through all the pins. So first finding the ngc folders and then brute forcing all the pins. Just for the demonstration, I created a simple pin, which would be 1254. So let's see if I can. 1254, okay, that works. So 1254, and using that pin, it is able to decrypt the clear text user password. So even if auto login was not enabled on this system, I would still find his clear text password because he uses a PIN code, and behind the PIN code is the clear text password, even on the newest Windows 11 systems. Okay, so far so good. We still do not have any cookies or passwords from a browser. So one of the other things that is part of this toolkit is browser decrypt. The browser decrypt actually is able to decrypt any cookies from any Chromium browser, which is most of the browsers right now. So we have Chrome, Edge, even Brave or another one, I forgot the name, are all based on Chromium and can all be used with this script. It has a lot of options, but the most obvious one is it's called a local state file. So we need that state file, which is actually located right here. So I will focus on the edge. Maybe I can open it up to show you how that looks like. So we have, for example, Facebook, and as you can expect, we have our Facebook, which is automatically logged in, as many users do. We have our LinkedIn page, which should also be automatically logged in if internet works, of course. Then we have, for example, Hotmail automatically logged in, so that works. What else do we have? We have GitLab, okay, verifying that we're human, okay, should work. So like this. Then we have, for example, Gmail. We have a Gmail account right here. We have Entra ID, so this user seems to be using Entra ID too. And as you have seen, not a single one of these asks for a password, because it is based on cookies, as you have seen in the previous video as well, right? In the part 1 of this series. So this is actually what we want to abuse. We are not really interested in passwords because they might use multi-factor authentication. So we are interested in cookies. So let's close the browser up again. So as you can see, all these cookies are in Edge. So we need Microsoft Edge. And then under user data, we have our local state. This is actually a file that contains encrypted master keys. So the master keys to store the cookies and to store the passwords are actually in that local state folder. However, they are encrypted in 2 different ways, actually. It used to be like 2 months ago, it was only one way of encryption, but now something has been added in October. The ABE, application bound encryption key, has been added as a separate way of encrypting the cookies, an extra encryption on the cookies, not on the passwords. So it's actually easier to get passwords than it is to get cookies. So it actually tells us what kind of files we need. So there will be files with this name and files with this name. These files are then encrypted as well, and we need the username and password, or username and hash, password hash, to decrypt these files, and then these can be used to decrypt the local state file or the keys in the local state file, and then these keys can be used to decrypt the passwords. Fairly simply, where are these files located? They are actually always, so these files are actually located in the same folder for every single system. They are located in users, and then the username, app data, roaming, Microsoft Protect, and then the SID of that user. So I provide these files with the the master key parameter, so he has found them. I have not yet provided a password, so this will actually fail. Too bad, it fails. And that's because I did not provide a password or password data, and it's trying an empty hash, so no password at all. Of course, that does not work. So what I have to add as a last part is actually to add the hash, for example. So this would be a hash for the user Philip, as we are giving him Philip's master keys. So let's try that out once more with the hash. Now it should be able to work, and it has worked. Success! It was able to decrypt the master key of the browser for the passwords and the master key for the cookies. These are the two keys. Actually, this is just a hash, just to show you that I can also use a password. We already know the password, so since we know it, why not use it? So this should just give the same result, of course. Okay, so far so good. Now we actually do want to decrypt the passwords, for example. So passwords or logins are actually found in this folder: users, app, local, Microsoft Edge, user, default, login data. That's actually the login data contains the passwords, and it has found 8 credentials, and it was able to decrypt all of them. If you want to see them, because I want to keep it a little bit clean by default, we add the verbose parameter, and now we can see all the passwords in clear text of all these users and all these websites. So all the websites that do not have multi-factor authentication, we can just now access. However, of course, we are mostly interested in cookies. Actually, the cookie parameter is not L for login, but C for cookie. And the cookies are actually stored somewhere else. They're stored in network cookies. So if I do this once more, we will see it has found 430 cookies, quite a lot. And it has been able to decrypt most of those cookies. Now I will do two things. I will show the cookies, but that's not so important because cookies are just some mostly rubbish or base64 data. I will also output them to philip.csv, for example. So this will just export the decrypted cookies into a CSV file. And it will also show them since I added the -v parameter. So these are the cookies for office.com and so on. So I will not just scroll through 424 cookies. However, we have now our cookies philip.csv file, which I can actually copy one folder over, and then I will open a new window, because for the next phase, the last phase, I will actually use the cookie injector script. So if you look at this, what this actually does is it parses Chrome, Edge, Opera, Brave exported cookies and turns them into a Firefox cookiespot.lite file, which means that it can create a new Firefox profile with the cookies already present. So I will actually just take the exported cookies that we have here, import them into an empty Firefox profile, and then launch that profile, essentially giving us a browser completely in the context of our victim user. So it's fairly simple to do that. We need the cookies file, and then the binary. In Linux we can just type Firefox. If we're on Windows, this also works, but I will have to specify the path to the Firefox executable. Okay, so that works, converted, and now we have a Firefox that is actually running in the context of the user. So if I now look at the cookies, for example, you can see that we have cookies for all kinds of websites. Facebook.com, okay, let's go to Facebook.com, and we should be logged in to Facebook.com as our user that is the victim right here. What else do we have? We have GitLab, for example, right? GitLab, we are logged in as GitLab. Hotmail, let's see if that works. Hotmail seems to open up, works as expected. Gmail was also one, I believe. Gmail, and it opens up and we see our Gmail, Entra ID, right? Again, with the cookies, logged in, bypassed. So now, of course, the hacker would add his own multi-factor authentication keys and maybe even trusted devices and other things, and it's a full phishing success like this. Okay, I would say keep learning, and thank you.